All right, in this video today, we're going to talk about complex fractions, and all complex fractions are a set of fractions divided by another fraction. By the way, this would be the exact same problem as 5/8 plus 2 divided by 2/3 plus 1. There are those implied parentheses. So you could even rewrite that just because, you see that divide sign. That's like a little tiny, the divide sign is a tiny fraction. So all we're saying is this set, there's an implied set of parentheses here divided by this set of parentheses. So we're going to have two different methods to simplifying. We're not solving anything. So if I say solve, I mean simplify. So a complex fraction is a rational expression that contains fractions in the numerator and denominator, or both. So one method to simplifying this would be to first combine the terms in the numerator and denominator and then multiply by the reciprocal. Because right now, if I'm going to divide fractions, I don't have one fraction here and one fraction here. I would have to simplify in order to multiply by the reciprocal. I can't take the reciprocal of just 2/3 because I want to divide by this whole quantity. Okay, so if we do that, if we simplify the numerator, what do I need in order to add 5/8 to 2? I need a common denominator. What's the denominator on the 2? A 1. So if I want to make a common denominator, what should I do with 5/8 and 2? What do I want to do to 2 so that I can add it to 5/8? Need to, 8 over 8, right? 8 over 8 is just a fancy way of saying multiply it by 1. So now we have 16 over 8. And that's all divided by, what would I need to do in order to add 2/3 to 1? By 3 or 3 over 3? Is that a difference? If I multiply by 3, is that different than multiplying by? Yeah, okay. So then I have 2/3 plus 3/3. Okay, so that's my first step. Now I want to combine my like terms, my fractions. So I'm going to simplify the numerator, simplify the denominator. I'm just putting parentheses there so you see that is a grouping, right? So what is 5/8 plus 16/8? 21/8. Good. Divided by, and then what's 2/3 plus 3/3? 5/3. Now my last step is I want to, I'm dividing this fraction by this fraction, so I need to multiply by the reciprocal of this. And the only reason why I'm going over this way instead of showing my work vertically is I ran out of room because there's another example down there. And I want to keep it on the same page. So I have 21/8 times the reciprocal. What's the reciprocal of 5/3? 3/5. Is everybody with me so far? Okay, now I want to look and see, can anything cross cancel? No, because that's the easiest way to multiply fractions is if you can cross cancel. So since nothing can cross cancel, I end up getting 63 over 40. And since nothing could cross cancel, that also means that my fraction is fully reduced. I don't have to worry about trying to reduce 63/40 if there was no common factors to cancel. Okay? Yes? Yes. Yes. Anytime you're adding fractions, you want to always have a common denominator. So it's a good idea if you see a whole number that you're adding to a fraction to put that over 1 so you can kind of remember that I need a denominator that's the same. Yes. Okay, when you're adding a whole number to a fraction, you can always give it the exact denominator because that denominator is 1, so you want to build it all the way up to 8. That's a great question. Yes. 8 over 8. Yes. If the so you're going to always use that denominator of the fraction so that you can get a common denominator. Great question. Okay, we have a second method, and the second method is really cool. It's kind of a little bit tricky, and you could do either method. You don't have to learn them both, but this is kind of a little bit fancy footwork, okay? So this one is, method 2 is done by determining the LCD of all of the fractions and then multiplying the numerator and denominator as shown below. Well, it's not shown yet because I'm going to show you right now. Okay, so what's the LCD? Since the denominators are 1, 8, and 3, what's the LCD of 8 and 3? Is going to be 24. Does everybody see how he got 24? And I should have said and 1, but we can always use that denominator. You can. That's one way. If they don't, 8 and 3 don't have any common factors, so there's nothing. So we can look at some other examples later, but you can always find a common denominator by multiplying them. Sometimes it's not the smallest. Like for example, if you had the fractions 1/6 and 1/8, what would be the lowest common denominator between 6 and 8? It'd be 24. And the reason why that is because they're both divisible by 2. So 6 is 2 times 3 and 8 is 2 times 4. They have that common 2, so you end up only needing to use the 2 once and the 3 times the 4 to get 24. You're looking for the smallest number that both numbers go into. If you ended up multiplying 6 times 8, you would have gotten 48, and that would work as a common denominator. It's just not the smallest one. Okay, let's go ahead and try this now. So if I rewrite the problem, I have 5/8 plus 2, and I'm going to use parentheses here, even though it wasn't in the original problem, there are implied parentheses, over 2/3 plus 1, and again, I'm going to use parentheses. Now, watch what's happening now. This is kind of crazy, but just bear with me for a minute. We're not going, instead of combining these, because that was a whole extra step, right? I'm going to actually multiply the numerator by 24 and the denominator by 24. Can I do that? Is that allowed? Because I'm just am I changing the value if I multiply by 24? But I'm not multiplying by 24. I'm multiplying by 24 over 24, which is the same thing as what? 1 whole. So I'm not changing the value if I multiply by 1. This 24 is going to get distributed to both, okay? 24 here, 24 here. So everything gets multiplied by 24. So now what we have is 5 times 24 divided by 8. I didn't want to multiply it out because I'm going to show you how you can reduce first. Plus 2 times 24 over 2 times 24 divided by 3 plus 1 times 24, which is just 24. Are you with me so far? I just distributed the 24 to both. Okay, now I'm going to be able to reduce. I don't know what 5 times 24 is, but I do know how many times 8 divides into 24. This is the idea of cross cancel. How many times does 8 go into 24? 3 times. So that reduces down to 3. Now I have 15 there. Do you see where I got 15? And there's literally, the denominator is 1. So the fraction is gone. It's a whole number now. Okay? And then we have 2 times 24, that's 48, divided by, how could I simplify this one down here? I could go 2 times 24 and divide by 3, but doesn't 3 go into 24? How many times? It goes in 8 times. So you have 2 times 8 is 16. What happened to 3? It became a 1 because of that reducing, the cross canceling, right? And then we have plus 24. And this is equal to, what is that? Is that 63 over 40? Which is the same answer I got. So we have 2 different methods. What I really like about this method is what it does is it eliminates the fractions. It's the same concept as clearing fractions, which is what we're going to be doing next time in the next chapter or the next section of the book, 12.5. We're going to be solving and we're going to want to clear fractions. We're going to want to get rid of the fractions. So that's what happens when you multiply the numerator and denominator by the lowest common denominator. You end up clearing the fractions. Any questions on that?